Good evening. Welcome to today's webinar. Arthur C. Clarke said that any sufficiently advanced technology is indistinguishable from magic. Today we are going to hear about one such magical technology, flexible electronics. Speaking to us today is Professor Siddhartha Panda, a chemical engineer who graduated from IIT Kanpur, did his MS at the University of Cincinnati and his PhD from the University of Houston, all in the area of chemical engineering. He joined IIT Kanpur in 2006, before which he was with IBM's semiconductor R&D in New York. His research is predominantly in chemical sensors for healthcare, and in particular with flexible, printable platforms. He is currently the head of the National Center for Flexible Electronics at IIT Kanpur, which has been set up with investment from the Government of India. So thank you very much for being here, Siddharth. We really look forward to this talk. He's one of the foremost authorities on the subject in the country, so we couldn't ask for a better speaker in this area. Moderating this discussion is Suraj Rangarajan, another alum of an IIT. He is from IIT Madras, where he did his BTech in metallurgical engineering. Subsequently did his MS and PhD in material science from the University of Texas at Austin. He's one of those people who have spent an entire career in one organization, which is Applied Materials. He's currently heading an innovation center where he and his team work in the area of emerging areas that leverage the company's core competencies in materials engineering and thin film deposition techniques. He, like Professor Siddhartha Panda, has a number of patents and publications to his credit. So thank you very much for being here, Suraj. Really appreciate your taking this up. So a few quick rules, housekeeping rules before we hand over to Siddharth. You can type in your questions at any point of time. We will take some questions along as we go along. Professor Panda will indicate when those questions will be, and Suraj will pick them up. But please make sure that you put them only into the Q&A box and not in the chat window. We will not be monitoring the chat window. We are going to be only looking at the Q&A panel for your questions. If you have generic comments, you're welcome to put them in the chat box. That's it for now. Let me hand you over to Siddharth. We also have Ashok Kamath, who will be also moderating this discussion together with us, and he'll be summing up at the end as well. So over to you, Siddharth.
Thank you, Sushila, for the kind introduction. And I would like to thank IIT Alumni Center, Bengaluru, for this invitation and this opportunity to present. So as I'm sharing my screen, I would like to extend a very good evening to all the audience from the IIT Kanpur campus. My name is Siddhartha Panda, and I am the coordinator of the National Center for Flexible Electronics here at IIT Kanpur. And I'm going to talk about flexible electronics and the future of devices. And I'm going to make this presentation in three sections. First, I'm going to talk about flexible electronics and give some examples of what do we mean by flexible electronics, and give a glimpse of what the future devices could be. And then I'm going to briefly mention how the manufacturing paradigm of flexible electronics is different from that of conventional electronics, and then give some market projections. In the second part of the talk, I will make a case for flexible electronics for India and show how this is an opportunity for India to become to play a role as a leading manufacturer in this field. And also mention how the current steps for strengthening the ecosystem in electronic manufacturing also bode well for the field of flexible electronics. Then we take a short break here for about 7 to 10 minutes and take some questions. And then I'm going to wind up with the last part of the talk, which will be on the work which is going on at the National Center for Flexible Electronics at IIT Kanpur, where I'll mention about the vision and the objectives of our center. I'll talk about what we have done so far, coming up with the state-of-the-art building and facilities, putting together a team, having the industry connect, and having the project started and completed, and give a few snapshots of the work which is being done. So let me start with the first part of the talk, which is flexible electronics. Now, the word itself, the flexible electronics, what it indicates is that we'll have electronic circuits on flexible substrates. And here is a picture which gives an example of a flexible circuits on flexible substrates. And what does it enable? It enables making them bendable and stretchable, and that opens up different applications. And this opens up different product paradigms which are not possible with conventional semiconductor and glass substrates. And there are several attributes to this flexible electronics devices, and some of them are listed here. These are flexible and stretchable. These are lightweight. They have a possible cost advantage, and they are rugged in the sense that the packaging and other applications may not be as stringent. And all these things add up to give an strong indication that the field of flexible electronics has the potential to revolutionize the electronics industry. So in the next few slides, I'm going to present some of these examples of flexible electronics as we see in the industry today. The first is flexible displays, and these are examples of OLED-based smartphones. And this one is from Samsung, this is from Motorola. And here is an example of organic LCDs as a bendable display. And here is an example of rollable OLED TVs from LG. And in fact, about a few years ago, this was considered to be a futuristic technology. And last year, this has been demonstrated. Then we have flexible lighting. And what we see here are examples of this OLED-based panels, which are made by LG. And there are several other also applications for these. Another area where flexible electronics has made its mark is in this flexible solar cells. What we see here are this organic photovoltaic solar tapes, and organic photovoltaics are the third generation of PV technologies. So we see these kind of tapes out here, and they can be now put in different, and they can wrap around different materials of different shapes. And that also enhances its ability to be used in different places. Then we have got flexible batteries. These are examples of lithium-ion batteries. Typically, these are polymer gel electrolytes. And again, these flexibilities of these batteries enable them to be used in a large number of applications and devices. Then we have got flexible ICs. This is something we are very familiar. I mean, people in the semiconductor industry are very familiar with the rigid wafer. And here, these are the different chips, and these are diced, and they're used for different applications. But now what we have is these ICs now are made on flexible substrates, and these will be diced and be used for different applications. Then we have got smart clothing. So flexible electronics provides the capability of giving additional functionality to clothing and thus making them smart. So there can be different categories of smartness. One, there could be passive smart in the sense that the clothing has devices by which is able to collect the information of the surroundings. It can become active smart in the sense that in addition to collecting information from the surroundings, it's able to react in a limited way. Then you can also have ultra smart clothing that in addition to that, it can adapt itself to the surroundings. So here is an example of a heated jacket which is used by the US Winter Olympic team. And there are many more capabilities which can be now added to these kind of clothing. For example, in addition to having this heaters, one can have a different kind of sensors. For example, one can have these ECG, EKG sensors for heart rate monitoring, EEG sensors for monitoring the brain activity, sensors for monitoring muscle activity, the respiratory rate, temperature sensing, and so on. So keeping this in mind, the several companies have already started working on it. And here is one example where these sensors have now been embedded in this clothing. And from this, one can get the information about the physiological conditions of a person. As of now, the focus has been mainly on wellness and sports activities. But this has the option of opening it up also for healthcare management. Next, we look at flexible sensors. When we talk of sensor, there are so many kinds of sensors, and in this presentation, I'm just giving just a snapshot of a few of them. These are pressure sensors, and these have got multifarious users. If you look at these kind of pressure sensors, these can be also folded or can take the shape of the body of interest. And here is an example of a seat where this can measure or map out the body pressure and can be utilized for getting ergonomic seating conditions. And here is an example of designing grippers. And here is an example where it can be used for arthritis testing. And here is another example where it can be used as for this crash test dummy, and so on and on and on. And here is a picture. Here are pictures of these image sensors, and an application of these image sensors are. And one application is to use it as for this fingerprint as a security feature in smartphones. And here is a picture of a flexible temperature sensors, and this again has multifarious applications. Then we look at flexible RFIDs. Then this is a picture of a tag, and this tag can be utilized in different packages. So what it does is this RFIDs now they enable to track and trace the different objects and also make them interactive. Now, in addition to this having interactive packaging, this RFIDs also have uses in pathology, in the field of pathology, and something which could be very pertinent for the conditions which are existing now. For example, when there's a huge load of the samples to be tested, and then these processors, these RFID processors, can help in tracking the samples and consumables so that all these things can happen in a smooth manner. Then let's look at the future. What was considered a futurist technology a few years ago is becoming reality today. So again, these are some of snapshots of the futuristic devices what people have envisaged, and there's a good possibility some of them are going to be reality in the next few years. So what I've taken 3 examples of such. One such example is that of sustainable cities. So this is a picture of a building, and let's imagine that this building is now covered with flexible solar cells. Not only the walls, but also the windows and our window curtains, so that they can now utilize the sunlight coming in and utilize this to power the buildings. Another work which is going on is coating these window panes with certain molecules that they absorb the sunlight, store it, and then they release the energy at a later time so that one can distribute the energy. And once that energy is taken up from the natural system like the sun, that can be utilized for lighting of this buildings and the city. Another area where flexible electronics has a huge potential to play is in this the IoTs, Internet of Things, because that requires a large number of sensors, and flexible electronics has the capability of providing a large number of various kinds of sensors. And this can be used for management of cities, for example, for emergency services, for transport, for health, environment, and many more. Another topic of the future is the human-machine interactions. Now, what if electronic devices can be compatible with human tissue? If that would happen, that would open the door for several applications in health monitoring, safety monitoring, prosthesis, robotics, and so on. But in order to do that, there are several demands on these devices, which include the device being flexible, stretchable, imperceptible, as one does not want to feel that this is something which is an external foreign body which is there. They have to be biocompatible and self-healable. That if something happens to a device, that it should have self-healing capabilities. And these flexible electronics-based devices have indeed shown these characteristics. Of course, there are challenges, but that's what research is for. And there are researchers who are working in this area. And there's a hope that we'll be able to see many more deep human machine interactions being possible because of this field of flexible electronics. Just to go a little bit deeper into health monitoring, let us look at the next slide. So let us see, this is the human body. And here are the different parts like the bones, muscles, vessels, heart, stomach, and so on. Now, these emit certain signals. Now, these signals can be monitored by these devices, which are on the human body, say the human skin. These collect the signals and then they transmit it, and then there is a analysis of these signals, and on the basis of that, one can get an understanding of what's happening in the human body. At the same time, the signals can be fed back, and then this also there can be devices which can be utilized for stimulation as well as treatment of some of this features. So again, going a little bit deeper into this electronic skin, what we see here are more specifics, like having a body fluid-based metabolite sensor, an electrolyte sensor, and an ECG and temperature sensor, and so on. And then taking these information and having an actuation that if a certain drug is to given, have the feasibility of having a transdermal drug delivery. And here is an example of a printed electrode on a human skin. And what it does, it measures the signals from the muscles, and so on. And so currently there is research going on many of these areas, and we can expect to see developments in the coming years. So having looked at these different features of what the futuristic devices could have a promise, now let us look at the manufacturing process of flexible electronics, and let us see how this is different from that of conventional electronics. So in this slide, I should show the typical process of conventional electronics which is seen out here. For example, like these are several unit processes which are involved in the manufacturing of the conventional electronic products. For example, we have this wafer frequent thermal oxidation, lithography, doping, chemical vapor deposition, metallization, etching, and so on. And these unit processes are used to build these chips, and this shows the cross-section, a typical cross-section of a typical CMOS chip. And here what we see are the transistors, and then there are the different stacks, and then these are the front-end application, the back-end applications, and these are the packaging. And this is what typically what we see in a typical CMOS chip, and these are the typical processes. But as far as flexible electronics are concerned, and especially with flexible printable electronics, the processes are different. So when we talk of flexible printable electronics, what we have is we print the different circuits just as we print, say, a paper using a regular printer. And I mean, that's the philosophy of it. So we have, in a regular printer, we have ink, which could be of different colors. We have a color printer, and we give a command. And then what happens is that different features, different shapes get printed on a particular paper, and we obtain the desired shapes on the paper, which could be a regular, which could be of any shape. Now, similarly, can we print circuits on substrates? And that is what we have in this flexible printable platform. So what we have is we have got different printing technologies, which could be non-contact printing or could be contact printing. And among non-contact printing, there are different kinds of classes of non-contact printing. There are different kinds of classes of contact printing, and we'll briefly go over some of them. So as far as non-contact printing techniques are concerned, one of them is the inkjet printing mode, which could be continuous or could be a drop on demand. We also have a slot die, and we also have this electrohydrodynamic system, and so on. And as far as contact printings are concerned, they are again of different types. For example, in the standard gravure system, we also have this gravure, microgravure offset system. There's a micro contact printing, nano imprint, flexographics, screen printing, and all of them have different different principles behind this, and that is for the nature of the ink. For example, if you want to print, the ink also has different properties. For example, a different density, different viscosity, and so on. And hence, one ink cannot be printed on any kind of using any kind of a system, and there are different kinds of systems. So what we have seen here are typically what we call sheet-to-sheet printing. Essentially, we take a sheet and print it. But also, what we can have here is a roll-to-roll printing. Just like a newspaper is printed, we can also print devices that way. So what we have is this is a substrate, and this substrate could be typically is plastic, but it could be paper, it could be cloth. And then what we have here is that as the substrate is being unwinded, it rolls. Then we have a substrate treatment. Then there's a printing which happens, and then we have a visual inspection of the printed patterns. And if any intervention is needed, we can have curing, sintering, and so on. So here is a photograph of one such process, and later in the presentation, I will show a brief video clip of one of such a printing process from the roll-to-roll printer we have in our center. And this schematic again gives a little bit more details about how this printing is done in the roll-to-roll system. So now let's look at the different paradigm which is posed by this by this platform of flexible electronics. This is the schematic of a transistor. So we have got a channel, we have got a dielectric, we have the gate material, the source, and the drain. And in conventional electronics, typical these gate electrodes are doped silicon. The dielectric typical is silicon dioxide or some other dielectric, and the active channel is primarily silicon. But as we move from rigid transistors to soft transistors, which could be either flexible or stretchable, what happens? We again use different materials. So what this shows is that we now need different conducting semiconductor and dielectric materials. And in order to dispense them, these materials have to be in an ink form. Now, once we have in the ink form, then what we do is these inks have to be again made compatible with the different substrates. And the substrates will be plastic, paper, metal, foils, or cloth. And again, as we saw earlier, the process steps are different. And again, a lot of process optimization and process development needs to happen. And then again, these have got different primary equipment and ancillary equipment. And again, this requires an encapsulation and packaging is different from that which is used for conventional electronics. So the manufacturing of this flexible printable electronics is different from that of conventional electronics. But at the same time, what I would like to say is that when we look at the different materials, there's a large scope of lowering the cost of the materials because of the very nature of the processes which are involved, and we'll talk a little bit about that in the subsequent slides. Now let's look at the market projections. The 2018 market was projected around $31 billion US. And then primarily they were in different segments. For example, there was a segment of this displays which were the main drivers of this flexible printable electronic devices. Then we had this logic and batteries, OPD, and then we had OLED lighting, we had printed and flexible sensors, and then this conducting ink. And this market is projected to grow. And what we see here is a projection of the flexible electronics market. And this is in billions of US dollars, and each bar represents about 10 billion US dollars. So in 2018, we were about 30, and by the time we reach about 2029, is expected to reach around 87 billion US dollars. So having said that, that is a very favorable market projection for this field of flexible electronics and world over. So I complete the first section by talking about the market projection, and then I make a case for the flexible electronics for India. Now, there have been discussions and that India has missed the bus as far as conventional electronics have been concerned. And again, this setting of these fabs have been a challenge because these are very capital intensive. But then let's look at what some of the advantages which India has. As we have seen earlier, flexible electronics involves primarily flexible printable electronics involves printing of materials onto flexible substrates. And these are the strengths of India in chemicals and printing. India is number 6 in the world as far as production of chemicals are concerned, number 3 in the world after Japan and China. And India is number 4 in the world as far as the printing industry is concerned. So there are anyway some inherent strengths as far as this printing of chemicals are concerned. As of now, we are not like India, we do not have printing of electronic materials are concerned, but at least the platform. And as I mentioned, setting up of a typical semiconductor fab is expensive. And if I give numbers based on my recollection, I think it was around the year 2009. And that time there was an estimate, it was estimated that setting up a single fab needed a cost of around 25,000 crores. And that was the numbers of 2009. Now, this possibly has been a roadblock or has been a deterrent for setting up such manufacturing facilities out here. But what we see in India is the backbone of the Indian economies are these SMEs. We have 43 million of them, which contribute to 45% of the industrial output, contribute to 40% of the total exports, and they provide an employment to about 60 to 80 million people a year and generate about 1.3 million jobs a year. So the belief is that these SMEs, perhaps because of the lower capex involved in this, the SMEs perhaps would be able to absorb this technology and set them up. And again, if you look at the market for the Asia Pacific sector for this flexible printed electronics, again we see that we are at the cusp of the growth. And hence, by taking the advantages of the platform which we have in chemicals and printing, and that we do not need such a high capex, and the fact that we are at the cusp of the growth, this gives an opportunity for India to take this, to seize the opportunities which are there and become a contributor, and not just contributor, but a leader in as far as manufacturing of flexible electronics is concerned. While we are talking of these inherent strengths, let us look at some of the things which have been happening recently. And I have a snapshot of a newspaper Business Today, and that is taken from, there's a news item is taken from June 3rd, 2020. And what it mentions here is that the government of India, through the Ministry of Electronics and Information Technology, has announced 3 schemes: the production-linked incentive scheme, the component manufacturing scheme, and the modified electronics manufacturing cluster scheme, totaling to about rupees 50,000 crores. And that is to strengthen the electronic manufacturing ecosystem in the country. And when this electronic manufacturing ecosystem in the country is strengthened, the field of flexible electronics will indeed benefit from that. And also what we are seeing is the response from the global industrial players. And this is a snapshot from a newspaper taken July 9th, 2020. And Samsung has mentioned that it has started manufacturing smartwatches in India at its Noida facility as a part of its Make in India efforts. So this seems to indicate a very positive field for electronics manufacturing and for further strengthen the ecosystem. And all these bode well for India to take up the manufacturing of flexible electronics and possibly become a leader. So here, having completed the second part of the presentation, we can take a break and answer a few questions.
Sure. Um, Thanks, Dr. Panda, for a lot of interesting data points and perspective on flexible electronics. There are more than 20 questions at this point, so I'll bring up a few now, and then we'll save some for the end of the discussion. Also, just to give some perspective, our company is working with Professor Panda and the NCFlexE on some of the areas that he had indicated, displays, sensors, and all that. So one of the questions was, are there collaboration opportunities possible with the center? Of course they are, and I think the next section will cover those collaboration opportunities. So I think there were a couple of broad areas. One, I think everyone was interested in the clothing example that you gave. And there were lots of questions on how do you do this printing on textiles, and then can you then wash it, and how does electronics survive that wash and things like that, recyclability. And so maybe you can address all of those together, and then you can maybe later address the very specific questions. The general thing was with respect to clothing, printing, and recyclability when you talk about flexible electronics inside clothing.
So when we talk of clothing, yes, there like when we maybe I can elaborate on this aspect. That when we have clothing, either we can have discrete devices which are now integrated onto the clothes, or we can print them. Now we can either print the clothes, or in fact one can use conductive and the conductive yarn to make a different kind of devices. So all these things are being worked on. And then again in our center also we have got programs where we are printing on textiles. And one such example and one application of such a one application is to make these textiles for this EMI shielding. Now coming back to the washability, yes, obviously that is where the research is needed, because now when we have an application that we want to put this devices on print them on clothes, and these have to be washed and have to withstand wear and tear. So that is where the research comes in, and that is something where the players who are in this area are indeed working on it. And that's where comes the developing appropriate materials and developing the appropriate technologies which can withstand these kind of things. Of course, there are many more things which are there. I mean, we can discuss perhaps more in detail like once the third part is over. There's a lot more things would become clearer when we present the third part. As far as recyclability is concerned, yes, e-waste is indeed a challenge, not only for flexible electronics, but also for our conventional electronics. And there are indeed programs and there are research activities where we can convert the waste to wealth. More specifically for the Indian condition, we do not have organized sectors where we are now we're extracting the useful materials from this e-waste. And again, there are a lot of discussion which are happening. There are a lot of discussions which are happening, and there are a lot of activities which are being planned as to how this e-waste is to be handled. Again, this is not only for flexible electronics; it holds for that entire field of electronics. But again, let me add, like one of the things of flexible electronics is that like one can again use substrates which are more environment friendly. For example, people are indeed working on this degradable paper. People are also working on this degradable plastics. So research is going on this area, how to address this problem.
Yes, thank you. So you addressed the question about the conductive inks that are used. And one of the questions was, when you finally recycle, all this will enter into the water and things like that. So is that being considered? Are the inks that are being used environmental friendly? and things like that. So the entire supply chain, all the cycle on how this is built, is recyclability being considered during your entire process? And I think that was one of the questions.
See, when we look at the functionality of the devices, right now our function is on a functionality. Now, obviously, once the lifetime of the device is over, then it is to be processed, or is to be and the material is going to be recycled. So that is a different sector. So as of now, to address a very specific question, like yes, in fact, what I'll show in the next part of the presentation, that's one, like there's one device, like for example, organic photovoltaics. Like this is now being done on paper, and that is taking into consideration that this is going to be more relatively more environment friendly. So indeed, those things are being taken into account, but like we don't have all the solutions as of now. But again, we have to, when these things have to go in parallel. Like we have to go ahead with the devices, trying to look into functionality while looking into the recyclability and other aspects.
Okay. One of the things that set off some alarm bells in people was when you started putting these into the body. I think people are now getting a little bit worried. Can they hack into that and things like that? And how biocompatible are these materials with the body and things like that? There were a few questions related to how electronics compatibility with the body. Have you done testing, and do you know?
So see, there was a time, okay, let's move away from flexible electronics. Let us look at some other implants. Right now, we have got pacemakers, which like putting pacemakers inside the body. Well, it's a accepted technology. Putting titanium implants in the bones, that's again an accepted technology. Again, these required like a reasonable R&D to find out, whether these could be implanted in the body or not. So now, as we go into the realm of having this electronic devices, of course, like there will be R&D is going on, and obviously there will be stringent tests before anything can become a mainstream technology. So that is one aspect of it. The second aspect of it is, can you be hacked or not? Yes, that's indeed a concern, because whenever you have an electronic device, there's always potential of hacking. At the same time, all these things have to have this end-to-end encryption. So whatever encryption technologies we have for other systems also have to be utilized for these systems. And again, there are different protocols which have to come up, which have to adhere to before this become fully mainstream.
Okay, then there seems to be a lot of questions on the VLSI portion and the electronics portion. So maybe you can help to sort of clarify that, right? There was some question on what generation technology it is. Can you use VLSI electronics into this and all that? And I think maybe you can clarify, the electronics goes on flexible substrate, and at this point we are not doing cutting edge electronics on this because we are using printed methods. So maybe that's a portion that you can address.
Flexible electronics as of today cannot match conventional electronics when it comes to complexity. The flexible electronics is not competing with conventional electronics. It's trying to complement conventional electronics in areas where perhaps conventional electronics cannot find solutions. For example, if you want to have a conformal, if you want to have a
GPU,
if you want to have a conformal shape, you want to have shape-friendly devices. That is something which perhaps conventional electronics will not be able to address. So we are not looking at a competition as of now. We are looking more as a complementarity, so that like it can further enrich the offerings which electronics devices have.
Then I think there was one series of questions on how these are powered. So because the way that you've described all of these, it looks like they are almost standalone, right? The question was, how do they get their power? So I think just like any other electronics, right? You have to have a source of power for that. Yeah.
That has to, yes.
Yeah. And I think the other thing that it was in your application pie chart. I think flexible batteries are going to be a big part of how flexible electronics also enters into the mainstream. Smart watches right now are a growing segment Actually, the latest data shows that Apple Watch is going to sell more than all the Swiss watch industry put together. So the powering of those watches, if your band can be a battery, right? That in itself can be a huge market. So I see the flexible batteries becoming a big portion of how flexible electronics makes it into mainstream, right? So maybe that's one area that you can expand on. The flexible batteries part, is the center doing anything? And there was a question on collaboration in that area.
Yeah, as of now, yes, we have a small program on flexible batteries. It's not mainstream yet, but if people are interested, we'll be very happy to talk to them and engage in. And we can talk about the modes of engagement offline.
Okay, and the last question in this session. So the question was on space. Are we using any of these in space applications and things like that?
Answer is yes. We have. I mean, the center has projects with Israel. Will be which will have applications for space, but for reasons we will not be able to elaborate it here.
Okay. So now we'll go to the second part of the presentation, and please continue to put in your questions in there, and I'll take them and we'll discuss more as we close the session. Over to you again, Professor Panda.
Okay, so in the final part of the presentation, I'll tell you about our center, the National Center for Flexible Electronics at IIT Kanpur. So this center was set up in November 2014 with a grant from the Ministry of Electronics and Information Technology and support from IIT Kanpur. And the vision of this center is to conduct R&D in the area of large area flexible electronics so that it helps to catalyze the development of domestic industry in this field. So what I would like to emphasize is that the vision statement of the center has the word industry in it. In order to realize this vision, there are several objectives. One, of course, is to have R&D in the field of large area flexible electronics so that it leads to, potentially it leads to manufacturing, partnership with, potentially it leads to manufacturing with the industry. At the same time, we also look at our objective is to facilitate the formation of the industrial ecosystem. And let me elaborate on this. What we have is like, because we do not have a background, we do not have the basics of flexible electronics in the country. What we have is that we have got the capabilities. For example, we have got the materials industry. We have got the printing industry, as I mentioned in the previous slide. But although we are number 6 in the world as far as production of chemicals are concerned, we do not, there's hardly any production as far as electronic materials are concerned. While we are number 4 in the world as far as printing is concerned, there's hardly any contribution as far as printing of electronic materials are concerned. The question is, can we now have the materials, the material sector, chemical sector, being the electronic materials or electronic chemicals? Can we have the printing sector move towards or open up their facilities or invest or go into printing of electronic systems? Now, even if these two sectors come together, we also need the equipment sector because we need specific equipment from them. How do we get all these people together? How do we get all the sectors together? So that is something which we want to catalyze. Another objective is to have entrepreneurship that incubate small-scale industry. As I mentioned, unlike conventional electronics, which is highly capex intensive, when it comes to flexible electronics, it is not. So which means there are several technologies which now can be taken over, and we can start incubating companies. We can start incubating companies which can take the technologies and eventually, hopefully, they grow. Another objective is to have national and international partnership, because we realize that one center will not have the capability to have all the technology components. Hence, strategic partnership is critical. And finally, human resource development. We need to develop the human resources needed to support the hopefully growing domestic industry. Now, this slide tells us the philosophy of this center. This center serves as a bridge between the academic ecosystem and the industrial ecosystem. We have the academic ecosystem, and there are a lot of ideas. Some of them are very futuristic, which come out from this academic ecosystem. But sometimes this idea remains simply as, you know what, just a proof of just a simple demonstration on a lab scale. And because of some lack of enablers, they are not able to reach the industrial ecosystem. And the role of this center is to provide this enablers, or provide a bridge between these two ecosystems. So in the academic ecosystem, primarily many of these ideas which are generated are taken up by the team here. And then, as these are taken up, we march along the technology readiness levels and go beyond the proof of concept and make a prototype, so that it becomes easier for the industry to accept. Now, in the industry ecosystem, there are different segments. There is a material segment, there's equipment design R&D segment, the product industry segment, and we have a strong interaction with the industry. And a preferred mode of interaction or engagement is the code development mode. That is, we have an idea and we have the industry join hands. So together, we take this up along the different steps, along the technology readiness levels, so that we minimize the time and we minimize the uncertainty as we go towards commercialization. When it comes to electronics, what is state of the art today is going to become obsolete tomorrow, and time is an essential factor. And working in the industry, and the rationale for working in the industry is that we cut down on the time and we can move to, and hopefully we can move to commercialization as soon as possible. So while doing that, we also provide education and training and support. Research support comes to the team here. So we are generating trained manpower which can now support the industry. And what I would like to say is that this is a case of an academic leadership. So now, let me tell what is it that we do in our sector. In the first half of the presentation, I showed you pictures, examples of flexible electronics, which are taken from what is happening across the world. We had seen a folded cell phone, or we had seen a rollable TV, or we had seen some exotic lighting. But what we are focusing on our center is trying to address the unmet technological needs of our country. So what are some of these unmet technological needs? Here, what we see are some. This is a picture of some this medicines, some tablets. It's estimated that a large number, reasonably large fraction of the medicines which are sold are counterfeit. Now, what in a center, what we have developed is anti-counterfeiting technologies. Another specific problem from India is to provide accessible and affordable healthcare, and more importantly, point-of-care diagnostics. That's something which you're working on. Another problem of India is food adulteration, and again, we are working on systems how to detect this adulteration of food. And again, there are parts of our country which still are off-grid. Can we provide energy to those parts of the country? At the same time, there are also several components which need indigenization, because we're importing them. Can we now come up with processes which can be taken up by the companies and have the integration? At the same time, can we come up with educational kits so that education now reaches a large number of and becomes much more effective to a larger fraction of the population? So these are the activities which we are taking up in our center. So now, as far as the center is concerned, I'll talk briefly about the building and facilities, and then I'll talk about the people. So we have faculty members and research engineers who are the core faculty members, who are the core members of our center. We also have project staff, and we have also industry personnel who are stationed in the center. So it's about 100 people who are involved in this. We have a strong industry focus. We have a membership model, and the number of past and present members is 21, and a large number of non-disclosure agreements have been signed, and many of them which are at a very advanced stage of discussions. And then we have a technology platform for develop the components and the systems. And then also we are also looking at different aspects of scale development. So let me start with the building. So this is the picture. This is the entrance of the building. It's a 6-storied standalone building, and with an area of 5,000 square meter. And there are thematic labs, and this shows the pictures of one such lab. And then we have an industry-friendly ambience. When I say industry-friendly ambience, we have a certain section of the building which is for our industry partners, who have the people who are stationed in our center, and that is kept isolated from the other part of the building for sensitivity issues. At the same time, when we work with different industry, we also ensure the sensitivity of the information, and there are many more things which we take care of. And here are the pictures of some of the facilities. So we have the state-of-the-art facilities, and primarily on this printing. So we have, and what I would like to say, the philosophy of our facility. We have all the way from the lab scale to the industry scale. So what we have, and this is something which we would like to showcase to the industry. And there are industries which perhaps would shy away from investing in this field of flexible electronics, even if they find it attractive, because of the risks which are involved. They would not like to perhaps invest in it. And here, this is where we provide a solution, a possible solution. All this equipment, what we have, are now open to the industry for their projects, if they do a project with us. So they do not have to invest on their equipment, rather they can utilize the equipment out here. So the things can be taken up at a lab scale, and then that can be scaled up all to all, and protein can be done to almost to industry scale. And this is an example of a roll-to-roll printer. It's almost of a semi-pilot scale. So many of these uncertainties can be addressed. And once a certainty has been established as far as the device and the process are concerned, then the industry can now take that up and now replicate these processes at their place. So this is something which we offer to the industry. So what we would like to say, that our center is a one-stop shop for flexible electronics. Now, I've talked about the building and the facilities. Then I talked about the team. These are the core members. These are photographs of the core members of the center. So these are faculty members and the research engineers, which also includes the chief operating officer. And what I would like to say is that most of these core members, there's the faculty members and the research engineers, they work in the industry, and more specifically the semiconductor industry, before they joined IIT Kanpur. And the collective experience of these members is more than 75 years. In North America, in Europe, and in Asia, apart from India. So this is what the experience which the core team brings to the table. And this is a very interdisciplinary team. We have got electrical engineers, materials engineers, chemical engineers, physicists, chemists, and so on. And all of them are under one roof in a building. In addition to the core team, we have our project staff. And our project staff, I mean, we have got there's a wide, I mean, we have got a variety of, they come with a variety of experiences. We have got people with PhD degrees all the way to ITI degrees, diplomas, and also we've got a large, and we have got a spread as far as the qualification of our project staff are concerned. So having looked at the team, now I'll go to the technology platform. So as I mentioned earlier, when we talk of flexible electronics, we are printing circuits on flexible substrates, which could be plastic, paper, or cloth. Now, what are we printing? We are printing different components like sensors and actuators, and these are driven by electronics and can have an energy source, and so on. So in order to have this technology platform, what we have is a technology matrix. So what we have on the horizontals are the different components like the thin film transistors, organic light emitting diodes, organic photovoltaic sensors, inks, and battery. And then also and on horizontals, what we have is we have the different subsystems and systems like memory logic circuits, flexible solar modules, and so on. And we have teams who have dedicated who have taken responsibilities for each of these different components, and then we have got, and there's a cross responsibility of putting them together, of integrating them into these different systems. At the same time, we also have this program on this device integration, and also programs on this large area printing and coding. So having said that, let me say, how do we go around interacting with the industry, and how does an R&D reach out to the industry? So what we have is, we have some baseline R&D activities which are going on in the center. And what we do is, we have a strong industry outreach. So we said what our capabilities are, and we also ask the industry what is of their interest. And if there is a match in the industry, sometimes we propose something that we would like to do, the industry takes it up, and sometimes the industry comes out with their requirement, which we take it up, and that results in an industry project. Or sometimes we go forward with our in-house R&D and like reach out to the industry at perhaps a slightly later stage, and again go through the same process. Or we go for a technology once, or otherwise, if we go to a high level of maturity on our own, either we incubate a company or we have a technology transfer. So we have all modes of interaction with the industry. So now let me talk about our industry connect activities. As I mentioned earlier, we have a membership model with the industry, and as of now, we have got 2 tiers of membership, and that that's based on the facilities and what the requirements are. And we have got 21 past and present members, and a large number of non-disclosure agreements which we have signed. And we hold an annual industry meet. We have held that annual industry meet both at IIT Kanpur, also at other places, so as to enable a larger audience. And also what we have is, we also have held roundtables and roadshows. If people from the industry would not be able to come to Kanpur, we have gone to them. So these are some of the places where we have had our roundtable and roadshows, where we have showcased the capabilities of our center. And there are a large number of trade shows which our center regularly participates in, both in India as outside the country, and only some of them are mentioned here. And there are a large number of industry associations with which our center is strongly engaged with, both in the country as well as outside the country, and only some of which are mentioned here. Now let me share with you some of the success stories from our center with the industry. As I mentioned, we have got engagement with the industry in all 3 ways: incubation, co-development, and technology transfer. So here is an example of a success story. A technology developed in our center has been incubated as a company, Transpax, and this company makes anti-counterfeit tags. And this is based on a very proprietary technology which makes 3D features. And on the base, and again, these tags are again have got attraction from various industry segments. And here is an example of a technology which has been handed over to the industry, which was developed a code development board. And what I would like to say about this particular part is this conductive carbon paint. And this is an example of indigenization. This company had given this challenge to our center. Can we indigenize some of this particular type of material? And our company and our center has successfully been able to do that. Another example is by the transfer of technology. Again, we have transferred a technology algorithm to make sensors smart to a particular industry. So these are the success stories. And as we speak, we are also we are working with several industry partners in different sectors. And this was one of the questions which came up during the question answer session. Are we working with space? The answer is yes. We are working with the strategic sector, both with defense and with the space sector. We are also working with companies on these variables for healthcare. Another sector is track and trace for the supply chain management. Another is on smart packaging, also for food adulteration, for materials validation. And as we speak, we are also closing with this our understandings with several companies, and we are going to have more engagements soon. So now what I'll do is I'll just give a snapshot of some of the things which are happening in the center. And let me start with inks and printing. And let me start with conductive inks. In our center, we have developed silver and copper ink, both for inkjet as well as printing applications. And this is what are some of the things printed shown here. And here is one example of this educational kit. So what happens here is that, like, whenever like one wants to learn about this electronic circuits, one takes a breadboard and like start playing around. Now, instead of doing that, this opens up a new paradigm of having a similar education, a similar experiments. So now what does is one takes a pen, which has conductive ink, another pen which has got resistive ink, and then draw circuits. And this also becomes more relevant when we have online education, that if students cannot go to school and have labs, they can take these kind of sheets and still have their play around and make the electronic circuits at home. And here is this example what I mentioned about this conductive carbon paint. And this is a demonstration which has been done at center, where a piano has been printed. And I don't have a video of this, but like for people who are interested, we can share this. And this one can just print a piano and play it. And coming to printing, there are different activities are going on. And here in the activity, we have got a printed heater for putting in jackets. And it's something which we have got prototype of this jacket, which was tested on our security guards on campus on December nights, and they gave a very enthusiastic feedback about the prototype which has been developed here. Here are examples of the printed RFID antenna. And here is the schematic of this printed electronic, the roll-to-roll line what we have here. And this gives a photograph of the line which we have in our center. What I would like to say is that this is one of the unique, it's a unique design. I mean, definitely Indian, perhaps one of its kind in the world. Now, this has got different modules. Now, this is something which should be of interest to the industry, because now what happens is, like, now the industry would need some of the modules, not all of them. So now these are very modular, which means whatever is not needed can be taken up, and one can take up the modules which are of interest and then utilize it for printing devices of the specific application. So this, again, the way it has been designed is that it mimics the industrial scale processing, and again, it's very modular and suitable for pilot, pre-pilot, even pilot scale processing. And what I would like to show is, in the next slide, I'll show a brief video clip of how we are printing devices on this machine. So this is these are some of the things which have been printed on this roll-to-roll machine, and I'll talk a little bit about the smart ID label later on. So let me now play this. Let me now play this small video clip. So this is from the roll-to-roll machine, the picture in our center, which I showed now. So these are the processes, different processes which are happening, and you can see that this is the plastic substrate, and you can see the different structures which are printed here. Okay, so now after having talked about printing, let me give a snapshot of what is happening in the field of organic light emitting diodes. Again, work is going on in the area of display, again for signages and also for lighting. And this shows what the different the prototypes and demonstrators which have been built for segmented dot matrix, for passive matrix OLED, which have been done much earlier, for packaging, and this for interactive packaging. And you can have this with this wearable cards and indicator and signboards, and again for lighting for different applications and so on. Another area where our center is working on is thin film transistors and memories, and this is a unique facility, and this unique capability which we have in a center, and this particular unique capability has drawn the interest of us, the space and the defense sector, as I mentioned earlier. And this shows the snapshots of some of the work which is going on in the center, and this has different applications in smart packaging, healthcare, and different strategic sectors and so on. And then there are several sensors which have been worked on. thermal sensors, gas sensors, aqueous metal ion sensors, biomarker sensors, again for different applications such as smart packaging, diagnostics, and wearables. And some of the things are shown out here. And again, we are working with several industries in this area. And next, I'll go to flexible photovoltaics. Uh, I think this again one question had come up during the break. Okay, are we being cognizant of the environmental aspects? So what we see here is that these photovoltaic modules are now being primarily developed on paper, and again the different application areas. This can be used in flexible electronic systems, or can be utilized as a replacement module charger. So these are some of the results of these modules on paper substrate. I'll not go to all these details, but what I can say is that like this again, the levels shown here are again very promising. So having said this, I close the snapshot with examples from system integration. And this, and what I would like to say is that again we are trying to come up with solutions which are typical, which try to address some of the typical Indian problems. Let me take an example here. This is an IV bottle, and what happens is that when the IV, this fluid in the bottle goes below a particular level and that's not taken care of, and that can pose a lot of problems to the patient. And sometimes like the medical person may not be around to take immediate action when the level goes down. So then can we come up with a system like can come up with a cheap system which can now help give those indications. So what and this is what I showed during this printing, this printing part. That here is a sticker which is now put on the backside of this IV bottle, and then when this level goes below a particular level, there's an alarm which beeps. So it can alert either the attendants of the patient or the medical person so that that appropriate actions can be taken. And here's another example of a flexible electron arc thermometer, where you know what we have, where the temperature measurement part is a variable one, and so that it does not disturb the patient. So we have so now as a close, I would like to say that like we are interacting, our center is interacting with a large number of organizations, institutions, not only within the country but across the world. So that's also helping us give a lot of there's a lot of interaction which is going on, which is helping us to learn about a lot of things, and a lot of collaborative work which are in place. So now I'd like to summarize what I have presented. That flexible electronics is an emerging segment of electronics, and it has a potential to provide solutions which cannot be done by conventional electronics. And I would like to emphasize that flexible electronics is not competing with conventional electronics, but rather is complementing the conventional electronics. And then we looked at the possibilities of future, and what we say is futuristic today, what we call futuristic today, few years down the road that could become reality. And we discussed on differences with regards to conventional electronics. And then in the second part of the talk, I made a case about for India, for flexible electronics. And we saw what are the elements in place which favor India to take up flexible electronics manufacturing seriously, and how the efforts are being made to strengthen the electronics manufacturing ecosystem. The third part of the talk, I presented about the work which is done in the National Center of Flexible Electronics at IIT Kanpur. We presented about the building, the infrastructure, the team, the industry interaction, the success stories, the work which we are doing with the industry, and what are the things which we plan to do. And again, I mentioned about that our focus is trying to meet the unmet technological needs of the country, and also talked about the different modes of engagement we have with the industry, like incubation, co-development, TOT, and with the continued support from our funding agencies, Ministry of Electronics and Information Technology and IIT Kanpur, we are set to accelerate these activities. So with this, I would like to conclude the presentation. I would like to thank you all for your attention, and I would like to invite all of you to visit our center. Of course, this may not be the right time, but when things normalize, I would like to visit the center and see for yourself what all we are doing. And this is our website. So that a lot of information of the center is there on the website. And this is the website of the center. If there are any further questions, please be in touch. Thank you again.
Thanks, Professor Panda. I think time for some water. You talked for a long duration. And I think you covered a large breadth of topics. There are a few more questions that came up during the discussion. I'll try to bundle some of them, and then we have close to about 20 minutes and we can do a little bit more discussion. There were some questions on solar cells. I think you did show some examples on solar cells. There were questions on what else are you doing on flexible solar cells, organic, inorganic, efficiencies are low, what can be done to improve them, and things like that, generally in the area of flexible PV. So maybe your thoughts on flexible PV and how they find a place in PV in general.
I mean, there are different there are different parameters. If you're looking at efficiency, well, then some technologies are indeed more geared towards them. But in our center, we are working on paper-based which are flexible, utilizing organic molecules on paper-based, primarily for the reason that, like, looking into the future, where, you know what, like, this will have lesser burden on the environment. The question is, like, okay, where that can be utilized. Like, if every technology sector has its own window where it can be utilized. Now, if you look at PV as a whole, yes, I mean, there's an entire gamut of technologies, and it's not possible, and there are different centers which are focusing on different sectors. And in this particular case, our center is focusing on organic PV and primarily on paper substrates.
Sure. Okay, then talking about substrates, there were lots of questions on what substrates you use. You mentioned some plastics, PETA. Are there preferred substrates for flexible compatibility issue with electronics? Things like that, generally on the issue of substrates. And then there were lots of questions on rare earths, given that we have this issue of rare earths being difficult to procure and some China issues and stuff like that. Can this be a substitute for that? I don't know how that, it's a difficult combination to play in, but just address the issue of substrates. What substrates are used, and do rare earths play in any of this from a substitution perspective?
When you talk of substrates, as of now, as I mentioned, like paper, for example, as far as paper is concerned, like there's been work which is going on photovoltaics, but also we are looking at some other applications utilizing paper substrates. Now we are also using plastic substrates, and also we have utilized cloth, as I mentioned, for making this conductive cloth for EMI shielding applications. So again, the utilization of different substrates again becomes specific to our end application. So hence we are using different flexible substrates for different applications, and then I think we can take it more on case-to-case basis as to why we are utilizing the substrate for this application. For example, like if to take a specific example, suppose we want to put a particular device on a particular, say, package. Now that what kind of a package perhaps determine what kind of a compatibility issues are. So I would rather like to invert the problem, saying that, like, we have an advantage that even if we take plastic, there's so many kind of plastics which are there. If you want to have paper, like, we can take paper. I mean, there's different types of paper. So depending on our end requirement, we can now utilize those. We can utilize various types of substrate for the specific applications.
So I think one of the follow-up questions there was the temperature thermal budget. How high what is the temperature that the substrate needs to handle for the process flow, right? It goes through different steps, right?
It depends. If you look at PEN versus PET, I mean, some of them can go up to, say, 300 degrees Celsius. Some of them may be up to 150 or 200 degrees Celsius. So again, if you look at it, like what I did not present here because of paucity of time, again, the choice of the substrate, again, I mean, there's so many parameters to choose. Because one chooses a substrate based on what requirements it meets. It's not necessarily that a substrate can meet all the requirements. So the way the choice is, the way it's chosen is based on how we maximize the benefit which a substrate has. So again, if you're looking for example, if there's a process which perhaps needs a slightly higher temperature, and especially we are looking at those flexible devices which undergo vacuum processing, some of them, perhaps would need higher temperatures. And for that, obviously, one would need to have a substrate which is able to withstand those high temperatures, which can go to say 300, for sputtering and other applications. On the other hand, if you want to have a substrate which is primarily done by this printing, at the same time you have a sintering which goes to maybe 120 or 150 degrees Celsius, you may not need those substrates which need to go to high temperatures. So again, the choice of a substrate depends on so many factors.
And follow up to that, I think the way the flexible electronics industry is looking at is to go towards a hybrid model, right? As we said in the beginning, electronics is better done conventionally, right? Where you want performance, and the functionality can be done by the flexible process. And how do you integrate those two and come up with a flexible hybrid electronics, right? And one of the questions was, in this center, do you do that, and how do you accommodate maybe soldering or something, conventional electronics into the flexible devices per se?
Yes. As of now, even at the world stage, I don't think we have all the components which are fully flexible and which meet those standards. So,
but I think the industry is headed in that direction. So I think we will get
going in that direction, yes. So there are some simpler components, relatively simpler components, which have reached a certain level of maturity, while some components, yes, like of course, which have not reached that point. So yes, so as far as the world is concerned, yes. In fact, like in many cases, what they do is they take this conventional ICs, and what we see is polished. It's polished and made so thin. Then what is mounted on then we have this surface mounted on these flexible substrate.
Sure.
So that, and when once they're made thin and once they're polished, so that what happens is that rigidity.
You make a ball and grid array and then just
yes.
put it on top. Right?
So those things are now handled up to a point. As far as the center is concerned, the answer is yes. We are also going by flexible hybrid approach. In some cases, like we have, like in some cases when the components, like some of the components which need a certain level of performance, but perhaps the flexible components do not have that level of performance. They go with this hybrid, with the conventional rigid ones. But when the sizes are so small and we mount them on a flexible substrate, that does not come in the way of our required conformality. So these are the things which are going on right now, and parallelly, the effort is being done to develop these fully flexible components. But again, that's a long road ahead.
And just a follow up on that again, with respect to the industry itself, what is the maturity in terms of manufacturing, yield, performance when you look at flexible electronics? What percentage yield do you get? What repeatability of products and all that? How is it comparable to the VLSI electronics in that sense?
This is still I would like to say that this is still an emerging field. So okay. Because this is an emerging field, see, well, I'm not talking about yield. Let's broaden the canvas. If you look at VLSI, of course, if you look at the design set rules, all these things are already well established. In a flexible electronics, is still emerging. So obviously, we cannot expect the same level of performance as far as the VLSI is concerned. But then that's a long way to go. But that's the direction in which the industry is heading. But as far as the specific questions are concerned, numbers and all, I do not have that with me, because perhaps an industry would, if they're willing to share, they could share the numbers.
Okay. Then switching applications, there was questions about photonics. Are you looking at photonics? And then there was also about antennas, millimeter wave and things like that. Are you guys looking at that? Is flexible electronics compatible with that kind of applications, both photonics and transmission antennas and things like that?
Yes, we are working on these flexible antennas. In fact, I've shown a picture of one such. Again, we are utilizing we are printing these antennas. And again, for possible, for this near field communication applications. I mean, that's where the initial work is going on. So the answer is yes, those kind of activities are indeed going in the center. As far as photonics applications are concerned, as I mentioned, like we have a program on organic light emitting diodes. And I showed the different applications, whether it is for display application, lighting applications, or making interactive, these wearables and other things. So all these activities are going on in our center.
Okay. Then another application was on gas sensors. Are we doing anything on gas sensors? What kind of sensors do we use? What kind of materials do you incorporate? What can you detect? Things like that.
Yes, we are working on GaN sensors, and in fact, there are two companies with which we are working with. All I can say is that again, this is with smart packaging and for food adulteration. And as for materials are concerned, again, we are utilizing materials which can have more like a room temperature processing. So that's all I can say as of now.
And that is a big area of interest from an India perspective, right? India is a big food packaging center, and I think this is an area where flexible is already used, and now you can build in more use cases on top of that. Then there were a few questions about paints. Where do you get these paints? Can I buy silver paints? Can I buy carbon paints? And who makes them? And things like that.
Well, there are companies which sell these inks, but at the same time, we are also in a process of incubating a company in our center based on technology development center on making of these inks. So that is something which should happen. We expect to happen in a few months from now. But if there are any specific needs, they can get in touch with us, and depending on the kind of needs and all, definitely we'll be able to give a response as to what we can do.
Okay. Then a couple more generic questions. Are there standards in this industry, communication standards and things like that? Like if you need to do Bluetooth communication, is there a standard that exists? Are there companies that we should be following in this space to learn some more? Which are the other centers that are working in this space and all that general knowledge, general learning areas?
See, right now when we talk of standards, again, there are standards for different sectors. For example, if you look at photovoltaics, that is one sector. If you look at display, there's one sector. Again, communications has its own standards. But as far as utilization of flexible electronics is concerned, that is something which that will more be taken up by the people who are working in this field of communications, and perhaps they'll be able to give a more specific answer to this question.
Okay. Then I don't think you can attend any webinar these days without the mention of COVID. So what are you doing with respect to COVID? Are you making any COVID specific device? And then somebody actually had a recommendation. Their point was we do a lot of teaching, we have to wear a mask. Can you integrate a microphone into my mask? So I don't need to take off my mask while teaching and things like that. So
there are, again, okay, very specifically, in fact, although I did not use the word COVID in my presentation, I did mention when I was making a presentation on RFID tags, and I did show a picture of how that RFID tags can help in this pathology, the field of pathology. So right now in a situation like this, when there's a huge load of samples to be tested, RFID technology again can play a big role. And again, if you look at this flexible RFIDs, again will play a very big role, which are so that the samples, it can be utilized for for tagging and tagging and for this shape to bring shape conformality for this particular sample tubes. Now, in addition to that, yes, in fact we are talking about it. There's some very nascent ideas. For example, if you have a mask, can the mask which exists, can some sensors be put in the mask itself? Can that also become, can that give information? So yes, these things are at a very nascent stage. So we are talking about it, and we'll see how we go forward with this.
And then there were a lot of questions on how do we partner with you, and we can, whenever things open up, we'll come and visit you and things like that. And then one specific thing, do you help with design aspects, right? I have an idea. Can you help design what the solution will be and all that? What more do you provide in addition to these materials and fabrication?
See, we are a national center for flexible electronics. So it's not that our electronics is flexible, but our approach is also very flexible. So question is like, okay, see, we don't say what we do we don't try to put it on pen and paper, because that tells if we don't say anything, which means that by default we don't do that. That's why we keep a very minimalistic information out there, because we are also growing as a center. Flexible electronics is also growing as a field, and we want to work with the industry. We want and we want to work for the industry. And we want to bring these products out together to the market, and we want to work at different levels based on our capability, of course. So, answer is yes. Like we do not have, like, definitely we're very happy to talk to the industry, because as I mentioned, the vision statement of our center has the word industry in it. So how to get in touch? Please drop an email, and that's how we start. Simplest way to get in touch. And I don't promise that we understand everything of what the industry does, but what I can promise is definitely we'll give a very patient hearing. And then if it's within our capability, we'll go ahead. If not, of course, we'll say that there's something which we cannot do. And we look forward to hearing from the industry.
One more phrase without which any webinar will be incomplete is graphene. Do you work with graphene, and then by association with other 2D materials, molybdenum, disulfide, and things like that?
Yes. Graphene, yes. In fact, graphene is being used in some of our devices. 2D materials, these are, yes, there are people working on, but it's at a very initial R&D stage, because we need to go beyond a particular stage before we start seriously utilizing that.
Okay, a couple more questions. I think there was a lot of confusion from 3D printing and the printing that is done over here. So maybe you can clarify for people what the printing here is. More like printing, gravure printing. This is printing that is done on paper, right? In that, whereas 3D printing is more of building up material. So maybe if that's something that you can explain in terms of what the printing that you do.
The 3D printing is different. Like, all you do is, like, if you want to have a 3D structure, and and also if you look at the dimensions, and these are reasonably larger dimensions. But here we are looking at, like, out of microns. Then that's the level of resolution which you are printing. Of course, we cannot reach the level of the sophistication what you have in CMOS technology. But what we are using is essentially we are looking at trying to print circuits. Like, we're trying to print circuits utilizing conductive materials, semiconductor materials, and dielectric materials. But indeed, we also utilize our 3D printers. Like, we have 3D printers out here for making some of the things which are needed for our systems. So we also have this utilization of 3D printing in our sector.
Thank you.
So one last thing, and I'll hand over to Ashok. So I think from my perspective, this is a field that has been there for a long time, right? People have talked about flexible electronics, and one of the things that needs to happen is scale, right? We have had lots of small applications, all of which have moved, but I think for this to go to the big arena, right, we need one big killer app, right? One app which takes a huge area, right? Because when you do roll-to-roll processing, you generate a lot of material at one shot. So you need an application that can also support that amount of material that you are creating. And I hope that with all these different opportunities and the things that you presented today, one of these become that killer app, and flexible electronics also gets its day in the sun, right? And thanks a lot. And I hand it over to Ashok to close this event.
Thanks, Suraj. Thanks, Professor Panda. Sushila had begun this session with something from Arthur C. Clarke. And that also led me to think about, there was a series in the mid 1970s called The Bionic Man. Some of us who are a little older may have seen this. The Bionic Man essentially ended up with a huge amount of flexible electronics. And we're talking about the 1970s, which today I think are almost a reality if you look at all the things that can go into the medical domain, right? What was fascinating is that Professor Panda took us through what he rightly calls unmet technology needs of this country. If you look at our big industries, automotive, a lot of opportunities there for flexible electronics in instrument panels, in under hood controls, in ABS and stuff like that. So I think there are lots of places there where flexible electronics could be used. Clearly in industrial and medical, there are dozens of applications starting from, glucose measuring strips upwards. I think there's a whole lot of things that could be done. And as India is becoming a recognized power when it comes to space and satellites and so on, flexible solar panels that can go up in spacecraft and perhaps even, drones and stuff like that eventually. I think, there are opportunities there in the strategic electronics area for us to play a big role. Finally, I think with all this noise around us, we are seeing that India is probably going to be a large center for making cell phones. And that's perhaps an area, where, as, Suraj was saying, what's going to be the killer app? I'm saying, could it be the cell phone, manufacturing area that could be the killer app, as many more phones are coming in with the flips and so on. So I think those are the areas. I think looking forward, we got a little glimpse of potential interdisciplinary research into base materials, bonding adhesives, metal foils. I think, those are areas where I think India could lead the way and, perhaps, dominate over time. So I think we got a fabulous glimpse into, all the magic that Arthur Clarke talked about. And thank you so much, Professor Panda, for, sharing all this with us. When this talk about bringing the National Center for Flexible Electronics as part of our webinar came up, very few of us actually knew of its existence, unfortunately. I think today we've had over 200 people who have been watching this, and at least 200 people will go home knowing that there is an area of technology where we are at the forefront. And so thank you so much, Professor Panda, for sharing this. Suraj, not possible to have these things without, a smart moderator, and you perfectly fit that role. Thank you so much for taking time off to do this.
Sure. Thank you.
And, we've had, I think, close to 100 questions in the Q&A box,
yep,
which has been, I think, some kind of a record. Sushila might be able to tell me that later on, but I think we've had a huge number of questions. I'm sure not all of them were answered to everybody's satisfaction, but then we had a 90-minute limitation on this. So thank you, audience, for being there. And for being there with us. This is our 15th webinar. Thank you for being with us. Many of you have been there from the beginning, and we hope that you will be with us as we conduct this concept every Saturday at the same time. So thank you very much, audience, and Suraj and Professor Panda, thank you very much, and have a good evening.
Thanks for the IIT Center for having us stay home and stay safe.
Thank you.
Thank you.
Thank you.